Ether gravity. Introduction. Johann Kepler discovered the three laws of planetary motion on elliptical orbits around the Sun. Kepler's third law expresses a universal relation between a planet's orbital period and the average distance of a planet from the Sun. Isaac Newton applies Kepler's principles of planetary motion in his law of universal gravitation. Newton's gravity equation introduces a universal constant g as a proportionality constant connecting the gravitational force between two bodies with the product of their masses and the inverse square of their distance. René Descartes formulated a law of transformation and conservation of force which causes self-movement in objects. Ben Franklin developed a first theory of electricity, according to which extremely small particles can create electricity substance, fluid, and a positive quantity of electricity, excess, or its negative quantity, shortage, was called by him an electrical charge of a body. Charles Coulomb experimentally established the law of electrical forces where the force is inversely proportional to the square of the distance between the bodies. Coulomb's law is mathematically similar to Newton's law and has the product of two charges in place of the product of the masses, and the Coulomb constant in place of the gravitational constant. One of the crucial points in the history of physics was Michael Faraday's idea of lines of force. According to his concept, particles mediators provide for a distant transition of magnetic force in the same way as a distant transition of induction forces. James Maxwell translates the idea of lines of forces into explicative mathematics language and develops a model of ether. In this model, the ether has a cell structure where the different kinds of excited ether particles' motion in lines of forces are described by means of electrical and magnetic state. The propagation of electrical and magnetic energy in the ether environment Maxwell describes in his laws of electrodynamics, which combine electricity, magnetism, and light into a single electromagnetic field. The unity of optics and electrodynamics was experimentally proved by Heinrich Hertz. From that moment, the ether was considered as the carrier of all electrical, magnetic, and optical phenomena. Thus, J.J. Thomson developed the theory of ether, directly following Faraday's ideas about force tubes. According to this theory, the electromagnetic mass was understood as the mass of ether itself. Hendrik Lorentz, in his electronic theory, identified Maxwell's electromagnetic ether with Newton's absolute space. He assumed that ether itself remains at rest, penetrates everywhere, but there may be various changes in the ether state, which we can observe as the action of various forces. Lorentz derived an equation to determine the force acting from the ether on the electron. In modern physics, the force of electromagnetic interaction is called the Lorentz force. But further development of the ether theory faced different obstacles. To experimentally prove the hypothesis of the fixed ether, Michelson and Morley conducted a series of experiments comparing the speed of the Earth with the speed of light propagating in different directions. It was assumed that according to the Galilean principle of relativity, the speed of light should depend on the direction of propagation, but the results of experiments showed that it was a constant. It became obvious then that the invariance of the light speed in the theory is incompatible with Galileo's principle. The only form of transition from the inertial system of reference to another. The concept of an electromagnetic mass questioned the idea that the electron has a mass in the sense of classical Newton's physics. In response to this assumption, there came a hypothesis that in general every mass has a purely electromagnetic nature, and there is no mass in the sense of Newton's physics. Max Planck solved the problem of black body radiation, which was at the forefront of theoretical physics. He introduces a quantum of energy, h, into the radiation law equation. It was called Planck's constant, and is the proportionality coefficient between a quantum of energy and electromagnetic wave frequency. On the other hand, the energy quantum of electromagnetic radiation contradicted the classical theory of thermal radiation, according to which heated bodies emit energy continuously. Apart from this, the theories of ether couldn't answer Newton's question raised back in the year 1721, why cosmic bodies gravitate to each other. To overcome the mentioned obstacles, it would require one to find the explanation of properties of an electromagnetic mass to move progressively at a constant speed of light, to form a quanta of energy in electromagnetic radiation, and to form motion of planets. Scientists could not resolve these questions at that time, and the classical physics was hindered from a progress by a number of barriers, one of which was the explanation of the properties of the ether particle mass. In the beginning of the 20th century, the quantum physics began to be formed. In 1905, Albert Einstein introduced the concept of the quantum of light, called photon, which is considered to be a carrier of electromagnetic interaction. This concept stimulated the development of new theories and gave a boost of experimental and theoretical foundations for the quantum mechanics, which describes the nature at the smallest scales of atoms and subatomic particles. In his general theory of relativity, Einstein derived the equations for the field of gravity, which connect the space-time structure of any object with its gravitational field. In 1924, Einstein came to a conclusion that the general theory of relativity envisages the existence of ether as a continuum which has physical properties. After the general theory of relativity, Einstein considered as the most important task to create a single theory of field by means of combining his theory of gravity and electromagnetism, which would allow for unification of the whole physics in general. The idea of returning to the ether was not accepted by the physicists of the time, and the search continued in direction of gravitational waves, assuming that these waves are similar to the electromagnetic ones. In the 1930s, Matthew Bronstein presented a theory of weak gravitational fields, according to which the gravitational field is a quantum mechanical system, and the gravity itself is the result of the exchange of gravitational quantum particles, that is, gravitons, between attracted masses, similar to the exchange of photons by electromagnetic interaction in quantum electrodynamics. In the 30s to 50s of the 20th century, the quantum and nuclear physics were rapidly developing. There were strong and weak nuclear interactions discovered, and later in the 70s, the standard model of particle physics was finally formulated, which describes the strong, weak, and electromagnetic interactions. The standard model was based on quantum field theory and is considered by scientists to be well self-consistent and as giving a very high matching between predictions and experiments. Attempts to quantize gravity in order to combine it with the standard model haven't stopped. The main barrier on this way is the compatibility in the Planck scale. Graviton is considered as a hypothetical particle because it is not directly observed. While the search for the gravitational field was successful, on February 11, 2016, it was announced about the experimental discovery of gravitational waves back in September of 2015 by the LIGO and Virgo observatories. What if there exists an alternative solution of the task to quantize the gravity rather than generally accepted methods of complex and abstractive mathematical models? For us to see the future, it might be reasonable to look back and to rethink the concepts of ether in the classical physics applying to them quantum models. With these videos, I would like to present a series of animations which explain my vision of gravitation. This concept is a result of my 40 years of work in theoretical researches and experiments with electromagnetic field. According to the concept, gravitation is a carrier of gravitational, electromagnetic, strong and weak interactions. It moves within the Planck's elementary space-time cell, and it is the smallest structural element of the universe. Gravitons construct the gravitational ether. Obviously, it is impossible to observe directly the collision and motion of gravitons in the elementary cell. The animation is a 3D reconstruction of a graviton dynamic state in the elementary cell. It is described by the equation I have formulated, as will be further shown in the video.